In 1962, for the first time in human history, the Yevta Center for Deep Space Communication sent a radio signal to other civilizations that might be in the universe. Even though we haven't received a reply for over 60 years, scientists haven't given up and keep searching for life beyond Earth. The scientist from the Leo Observatory went further and found a way to, so to say, see the invisible and indirectly find objects and even life in the remotest corners of the universe using special cosmic waves. The astronomers working with the Pan-STARRS 1 telescope might have even caught other civilizations watching us. So, can we also catch an alien spacecraft? According to the scientist, gravitational waves are mysterious ripples in the fabric of space and time that spread in the universe at light speed. They emerge when quite massive bodies accelerate. For instance, they can be caused by remnants of stars thrown back by explosions, black hole merges, or galactic collisions. Trying to detect this phenomenon would be the same as throwing a pebble into Lake Michigan and then trying to see the ripples spread on the water while being in the middle of Sydney. In brief, it was unreal until 1994 when investors granted talented California-based physicists $395 million to build an apparatus to detect gravitational waves. For it, the US built 2 observatories with special mirrors located for kilometers from each other. What's the purpose of such a structure? A gravitational wave is a tiny oscillation of space and time that changes distance between objects when it passes through them. Then the detector detects and registers the change. Thus, in 2015, the machine found a gravitational wave produced by a merger of 2 black holes, each as massive as approximately 30 of our suns. Moreover, the event was as far as 1.3 billion light-years away from Earth. After many successful experiments with those waves, Luke Sellers, a graduate student at the University of California, Los Angeles, found that not only black holes and stars could spread them. If an alien spacecraft enters our sector of the galaxy, LIGO could detect the gravitational waves it created. No doubt you immediately come up with a reasonable question: if LIGO registers the gravitational waves from immense objects that accelerate incredibly fast, how can it detect flying saucers, which aren't supposed to be larger than an ordinary airplane? The LIGO team explains that for their machine to detect the gravitational waves caused by a spaceship's acceleration, its mass can't be less than, for example, Jupiter's. But how do you build a spaceship the size of a planet? Well, you can do that without building it, but just use the planet as your transport. This hypothesis belongs to Irina Romanov-Sky, a professor of physics and astronomy at Houston Community College. She suggests aliens could travel on rogue planets. In 2021, in one of the Milky Way regions, scientists discovered about 170 such planets, each matching Jupiter's size. In total, in our galaxy, there could be up to 50 billion such planets. If extraterrestrial civilizations have found a way to accelerate them to near light speed, then when accelerating, such planets can create the gravitational waves LIGO could easily observe. Irina Romanov-Sky thinks such spaceships have many advantages, like constant gravity and ample space and resources, while their surface provides comfortable cover from dangerous space radiation. Though an actual spacecraft the size of a planet is also possible, such spacecraft can also be found in movies. The best match for the description of the hypothetical massive space bases is the Death Star from Star Wars. It's an enormous sphere the size of a moon covered with quadranium steel. Inside, it hosts a complex infrastructure of armories, command centers, and residential quarters for 2 million passengers. In the movie, it took 19 years to build it, but if Earthers tried to do something similar, we'd need a period of 182 times greater than the universe's age at $850 quadrillion. But superintelligent aliens could already have lots of such bases in different galaxies, and they could be much bigger than the Death Star. To register the gravitational waves from such a craft's acceleration and deceleration, apart from its size and mass, its unbelievable speed also matters. But what kind of fuel helps aliens travel in the universe so fast? Humanity doesn't yet know what could make a flying machine move at light speed or even faster, but well-developed extraterrestrial civilizations could have possibly found the necessary fuel for ultra-speed flights. This is what Bob Lazar thinks, a physicist who claims he worked in the secret Area 51. Bob says he, asking no questions, had a task to study a flying object and find how it worked to recreate a similar one. He thought it would be some kind of foreign military aircraft, but he faced an actual flying saucer that had obviously been in a crash. But the most amazing find was its reactor, which ran on the then unknown element 115. The study revealed it was antimatter made of antiparticles. But Lazar claims it could create specific effects that enable the spacecraft to reduce or remove the force of gravity. But there's more. On the top of the ship, there's an antenna that emits gravitational waves that completely enclose the spacecraft in an isolated circular gravitational field. To run the apparatus, you have to place a fraction of the antimatter and matter in the reactor, generating an immense amount of energy to activate the spacecraft. Even if we assume we could also find a way to travel at light speed, which is about 300,000 kilometers per second, it would anyway take us 25,000 years to reach the nearest galaxy. However, antimatter in the form of element 115 could potentially make it possible for us to travel even faster. It wouldn't be an exaggeration to state that Bob Lazar inspired and interested many people with the topic of alien civilizations. His stories about the element that makes a spacecraft move super fast, distorting space, were borrowed in many movies. The American sci-fi franchise Star Trek features a space-warping engine called the warp drive, allowing spacecraft to travel faster than light. But how is it possible in reality when Einstein argued no information could travel faster than light? It turns out it's possible to bypass his assumption, and scientists eventually substantiated it. Their explanation is the following: information is basically anything consisting of energy or matter. You, me, astronauts, and our spaceships consist of energy and matter, therefore, we can also be regarded as information. But the warp drive uses the only thing that's not information, space-time. Having no physical significance, it subsequently makes no information, which is why it can be made to accelerate to faster than light speeds. A warp bubble envelops the ship, compressing space in front of it and expanding it behind it, creating a kind of sliding platform. Then the ship slides along it, moving in the time-space warp at a faster than light speed. In short, flying machines that, owing to super-acceleration, can produce gravitational waves detectable by LIGO are theoretically possible and quite explainable by physics. Or are they not? The spacecraft Lazar claims to have seen wasn't Jupiter-sized. Does this mean LIGO can't detect the movements of extraterrestrial civilizations since their spaceships aren't like the Death Star? It can, as all these flying saucers are only dandelion fuzz. The draft document prepared by the scientists from Harvard University and the head of the Pentagon's UFO office suggests the idea that in the solar system there could be a giant alien mothership that sends tiny probes, nicknamed dandelion seeds, to explore other planets, including ours. So, perhaps Bob Lazar and others claiming to have seen UFOs don't lie, and aliens have been secretly watching us for many years. Still, one of such secret machines didn't go unnoticed and was even registered by scientists. In 2017, the astronomers working with the Pan-STARRS 1 telescope on the Hawaiian island of Maui suddenly detected the first space object to ever enter the solar system. They thought it was a comet, which they called Oumuamua. It traveled at the speed of 87 kilometers per second. Its strange shape immediately made scientists suspicious since it was unusually oblong, resembling a cigar. Then the researchers noticed it behaved unusually for a comet. At the end of its path, it suddenly accelerated. It even made sober-minded scientists assume the object could be a spaceship that could regulate its speed. Then the astronomers and physicists began searching for other theories that they thought were more realistic. For instance, according to one of those theories, it's possible that Oumuamua, just like most other comets, is rich in water. Before it entered the solar system, the water exposed to extreme cold froze, turning into amorphous ice in which water molecules are arranged in a somewhat chaotic order. Because of this, space radiation made the H2 and the H2O molecules split, and the hydrogen accumulated in the ice pores. After Oumuamua entered the inner solar system, it became so heated that it expelled the hydrogen from the comet. This caused an impulse which could explain the acceleration. But the fact is, in the years since Oumuamua's discovery, nobody has comprehensively explained how the object broke the traditional comet physics. And if the first thought that came to the astronomers when they saw the object is right, it means we found a real UFO. Aliens, smile, you're on candid camera now. We can also watch you watching us, and LIGO will probably pay closer attention to the area where the strange comet disappeared. Or a dandelion? We don't know yet. If LIGO registers many space bases that constantly move in space somewhere far, far away from Earth, what are you going to do? Will you be overwhelmed with sadness knowing that far beyond our system, there's exciting intergalactic life flourishing like a party you weren't invited to? Write your thoughts in the comments.